to the Book Doctor channel. Here, we demystify mathematics and make it fun.
We have to express y in terms of x. Given that dy dx minus 4y is equal to 3e exponent minus 2x. Given that y of 0 is equal to 2. The first step is to analyze the type of differential equation which is given. In solving any differential equation, the type of differential equation will determine the technique or the approach to that differential equation. The equation given is first order linear ordinary differential equation with variable coefficient. We can solve this by using the formula, or we can use the integrating factor approach and follow a step-by-step process. Let's try all the two methods. We shall start with the formula approach. A differential equation of the form y prime equal some function a of x multiplying y plus some function b of x has a solution y is equal to e exponent capital A of x plus e exponent capital A of x multiplying the integral of e exponent minus a of x multiplying b of x dx, where our capital A of x is the integral of the small a of x respect to x, and c is a constant. We'll write the differential equation in the form y prime is equal to axy plus bx. So this would be y prime is equal to 4y plus 3e exponent minus 2. In this regard, our a of x will be equal to 4. Then our capital A of x, which is the integral of the small a of x with respect to x, becomes the integral of 4 with respect to x, and that is 4x. Then let's substitute this into the standard formula. And the formula is y is equal to c e exponent capital A of x plus e exponent capital A of x multiplying the integral of e exponent minus a of x multiplying b of x dx. So we are going to have y is equal to c e exponent 4x plus e exponent 4x multiplying the integral of e exponent minus 4x multiplying 3 e exponent minus 2x dx. We simplify the expression for the integration. So the other expressions are copied exactly as they are. Then we perform this multiplication, and this will yield 3e exponent minus 6x Then we perform the integration. The integration of 3e exponent minus 6x becomes 3 over negative 6 e exponent minus 6x. We don't add the constant of integration because the constant of integration has already been dealt with in the formula. We simplify the expression further. This will be c e exponent 4x plus e exponent 4x multiplying minus half e exponent minus 6x. Let's perform this multiplication. You have c e exponent 4x plus, so here becomes minus because we are multiplying by a negative number. So minus half e exponent negative 2x. Remember, the multiplication is done by just adding the powers. So this becomes the general solution to the differential equation. However, the question demands a particular solution. So we use the initial values to determine the value of our constant c. The initial value given is that y of 0 is equal to 2. What this means is that when x is equal to 0, y is equal to 2. We will substitute this into our solution. And the solution was y is equal to c e exponent 4x minus half e exponent negative 2x. We'll substitute the pair of values. 2 will be equal to c e exponent 0 minus half e exponent 0. This becomes c minus half. We multiply through by 2, and we'll have 4 is equal to 2c minus 1. Solving further, we'll have 5 is equal to 2c, implies our c is equal to 5 on 2. Hence, the particular solution becomes y is equal to 5 on 2 e exponent 4x minus half e exponent minus 2x. This is the particular solution.